Like you heard, my name's Shannon Lauder. I've been a Microsoft data professional now for about 24 years. Uh, been a member of the past data community since 2010, as a lifetime learner as well as a regular presenter. Uh, I am certified in Microsoft technology, starting with SQL 2008 all the way through to current versions. I've also got my Azure Solutions Architect certification. Uh, I'm also really proud of the fact that I am one of only 9 certified BIML heroes. So that's a technology that helps automate data engineering workflows. Um, Primarily, it was for SSIS, and later it grew to cover Azure Data Factory, as well as it's been extended even further today to support many of the modern data platforms. But that was the single hardest cert I've ever gone after because uh, you have to share the code that you write on top of BIML to the guy who actually invented the technology. So not scary at all. And I'm really happy to say, uh, as of today, I have been officially welcomed into the Databricks Champion program. It's the Databricks equivalent of the Microsoft MVP program. So it's more about the training and the knowledge that I help pass along to the greater community, like sessions we're going to go through today. So let's hop right into it. So this is all about Unity Catalog. What do you get out of it once you've moved to Unity Catalog? Um, how does it make life easier? And what can you do? What kind of advanced things can you do on top? So first and foremost, how do you get there? How do you get into Unity Catalog? Well, if you were a customer prior to about 2 years ago, um, all the data that you create and store within the Databricks ecosystem, it's going to be exposed through Hive Metastore and external locations or mount points. And that's great for a single workspace. But as soon as you start spinning up 2, 3, or more workspaces and you want to share that data, prior to Unity Catalog, there simply wasn't a way. So a lot of the features you see today build directly on Unity Catalog. Um, we actually have been recognized, we being Blueprint, we have been recognized by Databricks with a Brick Builder Accelerator certification for our work in Unity Catalog migration. And at the very basic level, it's simply 3 steps that repeat. We begin with an assessment. We figure out what all Hive Metastore objects you have. What do you have in your workspace, like notebooks, queries, jobs, DLT pipelines, etc. We assess all that data, and then we work with you to take the assessment data and decide the what, where, and how you want to move those objects into Unity Catalog. And not to gloss over too much, but the configuration is critical because in our execute step, when we go to migrate these objects, it's critical that you have the configuration so we can move all your data or move all the code to where you want it in the future. Um, I will say a lot of the pain points in a migration come around code refactoring. Much of the code that you would write against Hive Metastore, you're referring to 2-part names, or in some extreme cases, you may be referring directly to file paths. Well, that code has to be updated in order to work in Unity Catalog because now we have 3-part names. We have catalog, schema, and table instead of just database and table. In those cases where you're referring directly to files, Unity Catalog tries to encourage you to move away from file paths and towards object references. So referring to the table, not the files underneath. If you have any questions about what it would take for you to move to Unity Catalog, please let us know. We'd love to help you out with that. We've got a bunch of different ways we can help. And yeah. So with that aside, let's talk about after we've moved to Unity Catalog, what all do we get? And this is small, so I will start to zoom in here in a moment. This right here, let's go ahead and zoom in, is taken from one of our internal testing environments. And we're looking at the Catalog Explorer. And in this page, what we're looking at is we're looking at a list of all the catalogs in our East US Metastore. So this environment is hosted in Azure, and it's in East US 1. So you can see a list of catalogs down the left, the data that's in our organization, and you'll notice a list of catalogs. If we click into a catalog, say Carpenter Curated, and we dig into a schema dependency sample, we then get this new detail page where we can see all the columns that are listed. And if we click on sample data, we can also see a sample of the first 5,000 rows of data in this table. So this metadata, it's great. All of it is stored in a news system catalog. So you can get at this data programmatically, which is awesome. And we're going to come back to in a bit. But I'd also like to point out, you now have the option to add tags. So on top of what we consider traditional metadata, table definitions, column definitions, key definitions, you now can tag many to many different terms. So if you've got a table that has PII, you could tag the table PII true. You could also tag an individual column PII true. And these tags serve to augment that base metadata to give you more configurability in how you consume and present that data. Let's also zoom in. If you click onto the details tab in your catalog, you're going to get all the information that you would have seen in Hive Metastore if you do a show table details. It's just now it's exposed here in the UI, as well as through those metadata, the system metadata tables I was telling you about. Additionally, once we're in Unity Catalog, your permissions are now tied directly to the object, and the object is stored in your metastore. That metastore is external to the workspace. So if you want to have one metastore that shares the data between two or more workspaces, you now have a single point of permissions. You don't have to go into each workspace and set up groups, users, rights, and permissions. You can come directly to the object, and you can set these permissions at any level. You can set these permissions, catalog, schema, table, object level, and you can also go down to the column level and apply masking and row level filtering too, if you'd like. And the key here is this exists external to the workspace, so it's a single pane of control. If you click on this history button here, what you'll see is a list of every operation you've performed against that object. So you can see the when, the who, and you can also see what type of operation. If there was an associated job or notebook, in this case, the operation was performed by a notebook, you can click in and go straight to the notebook that made the change in question. So this is all about discovering more information about the data in your environment. We also have lineage. So now we can see the relationship between our tables and our notebooks and our workflows or pipelines. We can even see the relationship between dashboards and tables. And you see these dependencies in both directions. So from this view, I'm looking for this table, what other tables depend on it. And it gives a list of those tables. And that's great textually. And you, again, can query this from the system catalog. But for most of us, it's more helpful to see this represented visually. So now you can see not only the tables that flow into other tables, but you can also see which columns from the prior object goes into the destination object. So this lineage is tracked all the way down to the column level. This makes it much easier if you're going to refactor a table to include extra columns, or you're going to change the data type of a column. You can now visually see what would be the impact of that change. Is another process consuming that column? It's all exposed here through the UI and through the system schema. So this makes it really simple to find, impacts to changes that you'd like to make. All right, so last but not least, we've got the Insights tab here. This is going to let you see, well, how often is this table being inserted, updated, deleted, or read from? How many times are we retrieving columns from this table? And by default, it's 30 days. We can turn this up to a longer period of time. We can also see subsequent notebooks that interact with our table, as well as we can see what tables are joined with that. So through here, you could start using this data to build new views. Let's say that there's a really high cost join between this table and impact results. Well, maybe through the ETL process, you'll persist a joined copy of the two and provide that directly to your consumers. That way, they can access the data more quickly without having to wait for that join to compute each time. We can also see, you know, dashboards that use it. We can see what users are most frequently in there, inserting or selecting from the data. And we even get at the bottom here, we can get a list of the queries that have been most recently run against that table. So this is all about discovering how your data is being consumed. And then this last tab here, it is in, this is in public preview, but you get, and this actually comes out to a link, so I'm gonna bring this over. There's this idea that if you want to set up monitoring on top of your data quality, so this isn't performance monitoring or optimization of your environment. This is simply if you want to keep track of how the data is changing over time, you can set up quality metrics to do statistical analysis, or you can apply simple rules and start calculating data quality as it moves through the tables and expose it through this Unity Catalog UI. So I've included the link in the presentation. We'll make sure to make that available for you if you'd like to look into it. The one thing I really need to point out here, again, this is monitoring data quality. This should not be confused with our Lakehouse Optimizer offering that we have here at Blueprint. Our offering is more around the performance and optimization of your spend and time in Databricks, whereas this is only concerned with data quality and how data quality changes over time. All right. Wrapping up the enhanced discovery piece of our presentation, I'd like to talk about the search function. At the top of Databricks interface, you've got that big search bar. Whatever you type in there, if you haven't already, try it out. Type in a search term. That term can be a table name, a schema name, a catalog name. It can also be a reference inside of a notebook or a dashboard, so you can search that way. This also searches tags. So let's go back to the idea from pretty early on where we created a tag to denote there were some PII in a given table or a given column. When you search, the tags are also considered as a part of that search. Pretty much the only thing that doesn't get searched is the content of a table or a view. It's not going to exhaustively go through all your tables looking for that search term. That would take just a little bit of compute to perform that kind of search, so it doesn't do that yet. But let's look at all the results we have here. Tables, notebooks, jobs, queries, dashboards, all of this is searched. And if any of these refer to your search term, they'll return in the main part of your page. So that's a ton of content all about discoverability in Databricks. Once you adopt Unity Catalog, I'd like to pause right there to see if anyone's had any questions yet. I don't see any in the comments tab of the presentation. Yep, just like the tag says. If you have questions, go ahead and pop them in there. I'm happy to answer questions as I go. I definitely prefer interactive presentations. I prefer talking with you rather than talking at you. So please hit me up with some questions or comments. All right. Now, you've heard me mention the system catalog a couple times before. I want to dig a little deeper into the topic. And if any of you have heard me present before, you know I'm a big fan of both metadata-driven design and automation. Well, the reason I'm so excited about the system catalog is you now have an information schema in Databricks. That means you can automate ETL processes. You can automate, you can make your jobs self-healing. You could make them self-tuning. A lot of the data you'd need to do all that is right here in your system catalog. So let's let's take a little tour real quick. So catalog, system, information, schema. If we start looking through the tables, we're going to see you've got a table here for catalogs and catalog tags. If you've tagged a certain catalog with a certain term, you can search this table right here and it'll tell you the catalog. Oh, looks like we have a question. Awesome. Is the catalog info accessible programmatically? Yes, it is. Great question. Um, any of you know the difference between a great question and a good question? A great question is one that is answered in the next slide. A good question is one that I have to answer on the spot. So yeah, all of that information is right here in your system catalog. Let's look at some more data we've got here. Let's back out and let's go down to the bottom of our list here. You can see here's a table for columns and column tags. So you can query these two. You can also join that up against tables over here. So you can get a list of all the tables that have columns that have a certain tag. You can join all these together. I would like to point out schema is a reserved word, so they couldn't create a table called schema, but they could call it schemata. That's your schema table. So you could go catalog, join to schema, join to table, join to column, and you've gone all the way down the tree. You'll notice extra things in here like table constraints. If you want to programmatically search tables that have business keys or don't have business keys, you could join to that. You could also query the privileges. So just like you saw on the permissions tab, you could actually query that. You've got table tags in here. You can query views separate from tables. So that's important. You can also query what tables have row filters. So if you do set up security to say group A can only see this subset of a certain table, group B can see this other subset, you can actually see which tables are having that performed as a row filter versus those that are performed as a view. So yes, all of that is available programmatically from the system schema, and it's pretty cool. In addition to your information schema, you also get this other schema inside of system called access. And if you've ever gone into the admin panel and looked through the advanced features, you saw the option to turn on auditing. And back in the day, you'd have to set up an additional storage account or S3 bucket for that data to get landed into. And then if you wanted to query that data, you'd have to set up some kind of ETL process to transform those JSON files, or I'm sorry, Parquet files. You'd have to transform them into a usable output. Well, now that same data is made available through Unity Catalog with no compute cost to you, the end user. It's made available right here. So under access, you'll see there's an audit table. This is a list of every event that's happened in your account since the beginning of time. Now it does build up, and you're going to want to use, query. You're going to want to filter that query so that your events are only looking at maybe the last 30, 60, 90, so that they'll come back faster. But I did also want to break down, here's the top 10 most common actions in our test environment. So you can see 187,000 selects to a table. 80,000 times we've listed queries that are available. We've created 46,000 objects. We've had a whole bunch of logins, both from user and from AAD tokens. So you could write custom queries that come into this table and tell you whenever anything happens. I would like to point out it is a lagged insert, so it can take up to 5 minutes for an event to show up in the audit table, but it does get there. In our environment, we do have 409 action names. I don't believe that's exhaustive. I think there may be others that I haven't seen yet, but there's quite a few. I also will say that inside the data, you're going to find a request parameter and a response. And this is going to be a JSON type column where it's a hierarchical column. Each event or each action type has a different payload. So for each action you want to query for, you're going to have to extract that payload to make sense of it. And it is documented. You can find it in docs.databricks.com, but it's not an easy task. So I just want to warn you that up front. So you can also look through here. Oh, this is a different table, sorry. Yeah, I believe that's everything. Just be aware it's difficult to pull that data out. In addition to your access log, we've also got, or audit log, we've also got column lineage. This is what backs that lineage diagram. So we've got column lineage and object lineage, aka table lineage. So in this case, we can see what entities are referencing a given table, and you can see the different relationships, a job to a table, a notebook to a path, a notebook to a view. It's all broken down here for you. So you can query that lineage data as well. It's very straightforward. Also, there are two other schemas under system that I'd like to make you aware of. These two, you will have to go into your admin control panel to turn these on. These two aren't turned on by default. So billing and compute. This is very similar data to what we're pulling in the Lakehouse optimizer, but now you can query it from the environment itself. So if you query the usage table here, you can see DBUs, how many, the quantity of DBUs consumed, as well as what the job was. And that usage metadata you will have to break down depending on what job type or what usage type you're talking about, but you could extract it. Additionally, the compute schema, that breaks down your usage of clusters and nodes within the cluster, as well as warehouse events. So in theory, you could use this data to recreate half of what LHO can do for you today. You can pull DBUs and compute, but you'd still need to tie that data to your cloud provider, whether it's Azure, AWS, or GCP. Not easy queries, but it could be done. And with 18 months and a dozen engineers, you absolutely could get the same thing as LHO, or you could just call us. All right, now I've given you a high level of data discoverability and things that you can, and the extended data that's now provided by Unity Catalog. Now let's talk about what can we do? What kind of advanced data management techniques do we have access to perform? So with this metadata, we can now build improved ETL processing pipelines. Think about it. You've got a list of all the tables that are available. You could build automatic transforms. If you wanted to clean up tables and exchange system names in bronze with human readable names, you could build that now. Awesome. We've got a new question here. Can I write rules based on catalog data? Yes, you can. So when you're talking about rules, are you talking about column and row level filtering rules? Or are you talking about a different type of rules? I don't see an update, so I'm going to start talking about column level filtering and row level filtering based on catalog data. So we do have a couple demos showing how you can restrict PII data in a column or in rows based on tags, as well as based on certain table names. So absolutely, you can write those kind of rules. Okay, here we go. Any useful in ETL. Yeah. So during the pipeline, we could use this data to say, all right, we're ingesting data. A certain column is marked as PII. We don't want to store that in plain text. We want to make sure that the first zone we land that in, it's encrypted. And then later in the pipeline, we want to take that encrypted form and provide one table for privileged users. And then we would decrypt the data, and only users who should be able to see the plain text would get access to that object. And then maybe another set of users, you'd want to let them only see a masked version of that PII. Yep, absolutely. Based on this metadata that we've got in the Unity catalog in the system schema, absolutely, we can set up that kind of rule, as well as encoding group names and what groups should have access to what. So absolutely, all of that is possible. Something that was very difficult to pull off with just Hive Metastore and show tables and show table description. So yep. So that's for both ETL and for our access controls. And those access controls we can now establish at any level. Oop, sorry, did not mean to click. We can establish those rules at any level. So catalog, schema, object, row, or column. And yeah, so that data is super useful. In addition, we can create enhanced data quality tooling. So I already showed the Lakehouse monitoring tools, but you can build custom functions on top of objects. You could write a function that does, let's say, an address lookup. And then once you've created it as a function, you can use that in your pipelines anytime a column comes through that meets a set of a list. Maybe you want to check address, address line 1, address line 2, city, state, and zip. Anytime that come through, you could call for that function and you could apply it automatically on those columns. So the sky's really the limit. Whatever you want to automate, if you've got data that can make that decision for you of should a certain thing happen or should a certain rule be applied, you can build it on top. We can also start building proactive solutions. So imagine building your jobs so that they keep track of how long they run and the compute type they use. And you notice a certain job is taking longer and longer each runtime. You could use that information to update the job to change the node types or change the number of nodes, and it would become self-tuning over time, both scaling up and scaling down. That's all possible now because of the system schema. You can make jobs that are self-healing. If you see a certain job failing more than so many times, yeah, a human's going to need to get involved. But if it's the first or the second failure of a job, you can always call for a retry based on the information in system schemas. I didn't go into it in a lot of detail up to this point. If you have the need to share data outside of your region or outside of your organization, Delta sharing is the way to go, and that requires Unity Catalog first and foremost. Delta sharing can allow you to set up a copy of your data that's only accessible to someone with a certain token or a certain level of access. And there's no limit to where that user resides. That user doesn't even have to be in Databricks. They could be a Power BI user or a Tableau user. And you could provide them Delta share access directly to the data, and their access wouldn't impact your compute costs at all. It would only impact your storage and egress costs. So this is another link that I'd like to share with you. If you haven't looked into Delta sharing and you have need to share cross-region or externally, definitely hit up this link to find out more. And finally, we can start to build dashboards that show us what's the return on investment for a given piece of data. So you saw we can look at how often an object's queried or how often it's referenced in a notebook. We can now quantify how useful data is. And we can use this to prioritize future work, or we can also use it to deprovision certain jobs and processes to save you time and money. Once data is no longer necessary for any use. So all of that data you now have access to in your Unity Catalog enabled environment. And I got a thumbs up on the rules.
Alrighty. Thank you so much to everyone who's joined this webinar today. If anyone has any further questions, please feel free to email us at info@bpcs.com. We'll be posting the recording to this webinar on our social media platforms, so keep an eye out for that. And Shannon, thank you so much for sharing your expertise with us today. Thank you all again for joining, and I hope you have a great rest of your Wednesday.
Thanks, folks.